Good morning, everyone. Enjoying the show? Good, good. Well, my name is Gary Russell. I'm the lead developer on the Spring Integration project and spring-AMQP, which is our abstraction over RabbitMQ. I also do some work in the Spring Cloud Stream area, of course, because that's sort of built on Spring integration. But today we're here to talk about Spring for Apache Kafka. This is a new project, although, as you'll see on one of the slides, it does have a little bit of history back to a Spring integration extension. Who's using Kafka? How about spring-AMQP? And JMS through Spring? Anybody? Okay, so a lot of the concepts you'll see here are going to be familiar to you, because what we've basically done is with Spring Kafka, we bring in the familiar Spring programming model, eliminating boilerplate, providing a Kafka template for publishing messages, message listener container for receiving messages, and as has been more recently added to JMS and RabbitMQ, a listener annotation, which allows for a very convenient way to use POJO, plain old Java object listeners. And we do have a project page. It's not currently on. If you go to spring.io/projects, it's not currently on the front page, but if you hit this URL directly, it'll take you to the project page. For that. So, as I said, it has a bit of history. So we basically have two projects. The Spring Kafka, it's currently at the 102 release, and it's based on the 0.9 Kafka client. We're in the process of producing the 1.10 release very soon after 102, because the 0.10 client came out, but has some minor API changes. So we decided to, rather than try and support both in a single release, we bumped it to the 1.1 release to support the 0.10 Kafka client. Currently it's only in snapshot mode, but we will be building a milestone soon. We're intending to probably add things like Kafka streams to that release as well. And that's the GitHub repo. And now Spring Integration Kafka, we do have, as I said, has some history. That Spring Integration has a number of core projects. Spring Integration users here, many? Okay. So Spring Integration has a number of core modules, things like FTP, JMS, RabbitMQ. But then we also have a number of extensions for Spring Integration, where the community have provided extensions. Sometimes community, sometimes actually internally, where we're not sure whether it's going to take become a full-blown module or of the Spring integration proper, or whether it just remains as an extension. So going back a couple of years now, we started out with the spring-integration-kafka extension. Originally it was in the extensions repo. It has its own repository, and that's currently at the 1.3.1 release, and that uses the 0.8 client. But it uses it directly. There is no Spring Kafka. So when the 0.9 client was released, which is a pure Java client, there's no Scala code anymore. We decided to break it out into a separate project, Spring Kafka, similar to spring-AMQP, just providing a low-level abstraction on top of Kafka itself, and then Spring Integration Kafka builds on top. The 2.0 release is a complete rewrite of the 1.3.1, just completely using the Spring Kafka capabilities. So let's look at some, what do we provide? So we start off with, we can define a bean. Now, I'll take a step back. Currently, we configure the Kafka client in a very familiar manner. We just use the standard Kafka properties, and as you can see here, we're just setting up a bunch of properties. And we did try and get some auto config into boot 1.4, but the sort of timing wasn't quite there. So whether it'll get into 1.1, we haven't decided yet whether it'll go into boot or whether it'll go into the Spring Kafka itself, but we expect to provide some auto configuration for the most common properties. But for now, you set up the properties. So in the case of the producer, we have this Kafka ProducerFactory that creates a single producer. If you use the same factory throughout the framework or throughout your application, as recommended by Kafka themselves, it creates a single producer. It's thread safe, and it's recommended that everybody in the same app should use the same producer. And that's what this default producer factory does. If your app calls close on that producer, it's just ignored. The actual producer, the single producer that's created by this factory, will be closed when you either the producer factory implements lifecycle. So if you stop the factory, the producer will be closed, or when you tear down the application context, because it implements initializing beans. So we only close the producer, physically close the producer, when everybody's done with it. So on the producing side, we have a Kafka template, and it's got a number of methods. I just put a couple out there where you can send messages. You can send them to a topic, a specific topic. You can send it to a particular partition within a topic. You can also specify the key, etc. So basic, just like the Rabbit template and the JMS template, we have the Kafka template. One difference is because Kafka is generally asynchronous, is the methods all return a future, or in this case, a listenable future, so that you can then you can either, if you want to be completely synchronous and you want to wait for that message to actually have physically arrived at the broker, then you can do a get on that future, or you can register callbacks to get the result of the send come back. On the consumer side, very similar, we have a ConsumerFactory. In this case, though, every time with the ConsumerFactory serves up a new consumer, you get a new consumer with the configuration. And for those not familiar, the group ID there means that that's a way of specifying a consumer group, so that if you have multiple instances of your application, they will if you use broker-managed partitions, the Kafka will spread the partitions across that group, so that you can get guaranteed order delivery within a partition. And then, so from the message-driven POJO perspective, we have this Kafka listener annotation, where you can just provide any POJO method, annotate it with the topic that you want to actually, or topic or topics you want to receive from, and then you'll get that data in there. Now, underlying this @x listener infrastructure, JMS, and for Rabbit 2, we actually have, the first thing that happens is the Kafka message gets transformed into a Spring messaging message, which has headers and payload. And so the second one shows how we can actually retrieve metadata. Even in our POJO method here, we can retrieve metadata about the message if we need to. So things like what key was provided, which partition this message was received from, and of course the topic if you have multiple topics. With this these two definitions, where we've defined either a topic or a regex pattern for the topics, these imply that the broker is going to actually do the partition assignment and will determine which instances get which particular topics. If you want to do explicit assignment, you can extend the annotation with these @topic partition elements, and you can optionally request the offset to be changed during subscription. So when we subscribe to the topic or a particular partition within the topic, we can reset the offset. So that's the Kafka listener. Underlying that, and then for those of you familiar with the Rabbit listener and the JMS listener, we need underlying this mechanism, we have a message listener container, and so we need a factory to be available to create those message listener containers. And the default factory we look for is one called Kafka Listener Container Factory, and where you can provide basic configuration. As you can see here, as an example, we provided a JSON message converter to the factory. So you can configure the factory so that the listener containers that are created for these @Kafka listener methods is customized for the for each one. But you can have as we'll see in some of the demos, you can have multiple listener container factories with different configurations. So that's the sort of POJO message listener. If you want to take it down a level and just want to use listener containers directly, then you can define a message listener container. We actually have two. This one is the Kafka message listener container, which only has a single thread, so all the partitions will be assigned to it, and everything will happen on a single thread. We also have a concurrent message listener container, which effectively wraps n Kafka message listener containers. The way that works is, if, let's say you have a topic with 5 partitions, and you set the concurrency to 5 on the concurrent message listener container, then Kafka will effectively balance the partition, so each of those threads will get one partition. So again, you'll maintain order within the partition. And then, so again, at this lower level, rather than a POJO listener, if you've got a listener container, you provide a listener bean, and it's just a simple on-message method, and then the argument to that method is the consumer record, which is the object that's returned by the Kafka consumer. In some cases, I'll talk a little bit more about committing offsets to the topic in a few minutes, but in some cases, you actually want to do that programmatically rather than have the container or Kafka commit those offsets. And so we also have a second type of listener called an acknowledging message listener, where you actually get 2 arguments. You get the record, the consumer record, and you get an acknowledgement object. And then at some point during your processing, you call acknowledgement acknowledge. So this allows you to, you don't have to do it on each one, but you could do it, whatever criteria you require in order to commit the offsets. In addition to the listener container and the message listener, we also have these listener adapters, which basically is a mechanism by which we add behavior to the listeners. So, and out of the box, we provide a retry adapter and a filtering adapter. And these are simply message listeners themselves that delegate to your message listener, and then you inject a retry template in the case of the first one, or you provide some filter criteria to filter. So these are just wrappers effectively around the listener, and we do, if you're using the @Kafka listener annotation, you can also configure them into the listener container factory. In addition to the spring-kafka jar, we provide a spring-kafka test jar, and this has a couple of things. It has it basically hooks into the Kafka server test embedded Kafka server, and so it gives us the ability to, and we'll see that in the project tests themselves, where we use that to create an embedded server, define some topics with some configurable partitions, and then run some tests. Some additional utility methods. For example, one of the issues with it's not really unit or integration testing with an external broker or even an embedded broker is timing, right? So we want to send some message to a topic and verify that we received them, and if you do it too fast, then you won't get them, right? So there's a utility method there to wait until the topics have been assigned by Kafka and that everything's settled down. And once that has happened, then we can start publishing. And it makes the tests more resilient. And then a couple of other things like there's a utility method for setting up a consumer and a producer and some matches for Hamcrest and assert J. I just want to take a minute to talk about committing offsets. We don't currently support an external offset manager. We're using the internal Kafka offsets. There are some quirks with the way that the consumer works. The consumer is not thread safe. The only method that another thread can call on the consumer is things like, well, is to wake up the consumer. So if it's blocked in a poll, you can wake up the consumer. One of the issues is, a pretty big issue is if you have a slow listener and and exceeds the session timeout, then Kafka is going to go into a rebalance. He's going to think that this consumer is dead, even though it's processing well, but it's slow. Kafka is going to think that that consumer is dead and rebalance the partition across the ones that it thinks are alive. And maybe that's what you want, okay? But in most cases, that's not what you want, right? You want to actually prevent that rebalance. You're working fine. You just need the thing to slow down a bit. So the client does have a pause and resume feature, so you can basically tell the consumer, stop sending me messages. However, in order to call that, as I said, it's not thread safe. It has to be called on the same thread. Well, if your thread is in the listener doing some long process, then you can't sort of get back and call the pause to pause the thread. Or pause the consumer. The second thing that it does is that while it's paused, we're still polling the consumer to say, is there any data, and that works as a heartbeat back to the broker. So now the broker, when we're in a paused mode, we're still polling. He doesn't think that, he knows that this particular consumer is not dead. He's just doesn't want any messages yet. And then when the listener catches up and everything's cleaned out, then we can resume that thread and continue to retrieve messages. So the way that we implemented that in the Kafka listener container is there are basically two threads. There's a thread that's polling the consumer to get messages, and then there's a thread that's invoking the listener. And we manage the two, and we're watching what's happening between those two threads, and then that's how we invoke the pause and resume and keep track of stuff like that. The one caveat with that, though, is that I should take a step back. The container provides a number of ways to commit or to commit the offsets. We can either do it by batch, which is like when Kafka gives us 10 records, then we'll actually commit the 10 at the end when we've processed all 10. We can do it by record, which means that every time the listener invokes one, then we'll do the commit. And there's a manual one which we saw with that acknowledged listener, where the container doesn't do the ACK at all. It's up to the listener to acknowledge to commit the offset by calling the acknowledgement method. Now, there's another option, that is you can configure in the consumer properties. You can say I just want Kafka to auto commit, right? So the problem with that is that that's actually done on the consumer thread, right? So in this two-thread scenario where we're having to manage, we want to deal with slow listeners, and we want to keep the polls going and pause and resume and all that. If you turn on auto commit, it sort of breaks, right? Because it means that the consumer thread gets the message, hands it over to the listener, and then goes back into the poll, which does the auto commit. So now you're going to commit before that listener is actually processed. So auto commit is a bit of an issue, to be honest. So we generally recommend not using auto commit and let the container do the commits, or do them manually yourself. The caveat is, though, if you do turn on auto commit, because of this issue about the early commit, we effectively disable this two-thread scenario, and we actually invoke the listener directly on the consumer thread to avoid this early commit. And the net result of that is if you've got a slow consumer and you're using auto commits, then you're back to the problem with the broker doing a rebalance, because if he thinks on a slow consumer, he thinks you're dead. So that's just a sort of heads up. I think auto commits are a bit evil, to be honest, given the current architecture of the consumer code. So with that, let's look at some code. It's I'd say very early in the project's life. I put a plug there for contributions. We already have a number of community contributors, so definitely looking forward to some more. So this, the code that we're going to go through here, there's a SpringOne platform organization, SpringOne platform 2016 organization in GitHub, and there are a number of projects out there. Oops, I'm not up. But this particular thing we're going to go through here is this G. Russell spring-kafka project, and there are a number of apps. They're all boot apps that we're just going to go through and look at some of these capabilities. We don't do any auto provisioning. Like if you want to run these apps, you actually have to go and create the topics manually. So let's take a look. So the first one is, let me see. I'm just going to fire up. I don't think I have one running. No. I should have done this before. No, hit the wrong button. Okay, so this first app. So each of these, as I mentioned, so each of these they're all little boot apps, and they're all in like a different package. So we got app 1, app 2, app 3. They use this common configuration class where we set up a ProducerFactory. We got a KafkaTemplate that's configured. We got a ConsumerFactory, a bunch of the consumer properties for that, and a couple of listener containers. As we go through, a couple of listener container factories. We'll go through those a little bit later on. But the first application is simply a boot app. We have this test bean that gets the Kafka template that's set up there as auto-wide, and we're just basically sending a message to the topic. The boot config, we've got here the broker address, which is obviously running my local machine, the topic. There's another topic for some of the other tests later on, and then I turned off JMX. So all it does is send a message, and the The boot app is configured. We get a reference to the test bean, and we call, and we're just going to send foo to the topic. So I'll run that, and on the console consumer, we should see that. Oh, there we go. I'm looking in the wrong. Oh, I must have. Oh, I already had a consumer running, that's why. There we go. Let me just run it again. And so we got foo. So pretty simple. First, sort of like a hello world for Spring Kafka. Send a message to Kafka. The second app now is actually we add a listener. So we're doing the same thing. We're sending a message. I added some code here so that I could sort of close it down cleanly. The listener has a latch in it. So again, the test bean, we have a KafkaTemplate. We have the properties in order to get the topic that we're going to send to. And now here's our Kafka listener. It's got a latch so that we can sort of shut down the app when it's finished. And as you can see here, we're using you can use property placeholders in here. You can use spell. As we'll see in another example, that there's a lot of configuration that you can do using the application YAML file. So now we run this one. We should see this receive message. So this yeah, it's been a while since so I ran some tests yesterday. So we got some additional messages because the offset was off. But so I run it again. And we got the foo message. As I mentioned in the slides, we can get additional information about the message. So this third example shows this mechanism here. So I now changed my listen POJO method to not only get the payload, so I annotate the payload parameter with that payload, and now I actually want to find out, well, which partition did this message come from? And in this case, I have five partitions. I'm going to send 10 messages, and we should see that the results came from each of those partitions. Okay. Now, in the case of the next example, we're actually showing how we can, instead of letting Kafka assign the partitions to our listener, where we can actually explicitly say, I want to listen to specific partitions. And again, in here we can add a spell expression, we can add property placeholders, so we can like if you for some reason need to do a manual partition assignment, you can deploy the same app multiple times, perhaps with different application properties in terms of which instance is going to subscribe to which partitions, and whether or not you want to change the initial offset. In 1.1, currently this initial offset, if it's positive, it's just an absolute position in the topic or in the partition. If it's negative, it's actually relative to the current end of that partition. So you can say, I want to subscribe to this partition, but for whatever reason, I always want to get, no matter where that, no matter what's in that partition, I just want to get the current last message from that partition. So you could say -1 in this initial offset. In the 1.1, we have another argument there, another attribute to say what it's relative to. So that if it's relative to the current partition or the current position for this group, then you can say, I want to get I resend the very last message that I received, or you can do it relative to that end. Yes. Well, I think I'd have to test it, but I'm pretty sure if you just put like integer max value, it would set it to the n. You can there is a property that you can set if you're using automatically assigned. If you're letting if the broker's assigning the partitions rather than use these explicit values, you can say. You can set whether, and this consumer has not actually connected to the broker yet in terms of this ID. You can say, set me to the earliest or to the latest. So in that case, you can do that. But for manually assigned ones, I think you just have to set it to a big number, and that'll put it to the n, seek to the n. I'm pretty actually, now I said that, I think as I say in 1.1, you can say relative to current equals true. So if you said initial offset 0 relative to current, it would send to that. Or you could, we'd have to think about that. I'm sure there's a way of doing it. But maybe we need to, we may need to add that as an option, because the consumer does have a seek to end method, which is how we do like if you do -1, I say I want to get the current end -1, so we seek to end, and then we position back 1. Yes. So the question is, with the console consumer, you can do --- from beginning. That uses. Right, but that's because it's the reason that works is because it's a new consumer. It doesn't have a consumer group. So back in this configuration, you see here I have where is it? I have this group ID config. So this group exists already, and Kafka has managed an offset for that group. With the console consumer, it's always a new group, so it'll always either be earliest or the end, depending on that from beginning thing. Where were we? Okay, so this is a way. Do people generally let Kafka allocate partitions, or do you manually do them? What's the consensus? I'm sorry? You've always just let the broker do it, yeah. Sorry? I don't really have one, I just write frameworks. So what was that? That was that one. So was there a question there? Okay, so all of these tests so far have been just sending simple strings. As you saw in the configuration, I was setting the serializer for both the key and the value to a string deserializer. So it's just basically taking the string and converting it to a byte array to actually what gets sent to Kafka. But there's a couple of things that we can do in terms of if we want to send richer data. So the next example is we're actually going to send an object, and we're going to use JSON. We're actually going to convert the object to JSON. So instead of using that common configuration, I've got a second JSON configuration, which is basically the same thing, but now the key serializer is a string serializer, and the value serializer is a JSON serializer. So this is actually something that provided by the framework. And on the deserializer side, it's a bit more complicated because you have to tell the deserializer what object you want to create from the stream. So this particular configuration is very similar to the first one. but it now has JSON serializer and deserializer for the values. And in the application now, we're actually, let me just pull these domain objects up. So we've got this very simple domain object called foo, which has got two properties, foo and bar. Okay, so so the application creates this foo object. Now I'm gonna change my console consumer here to listen to a different. This one too. And so I'm now sending this foo object because it's going through the JSON serializer. Obviously, it'll become JSON. On the listener, we've also configured the listener container. If I go back to the listener container factory, it's using the JSON deserializer on the inbound side. So let's run this one. This is number 6, I think. Forgotten where I am. 5, oh, so it's 4. Okay. And we got back our foo, and as you can see from the console, we actually did serialization to JSON. Now, that's one way of doing it. One thing I really am not keen on about that is the fact that we have to hardwire the target type into the deserializer, right? So we actually have another mechanism to do this. The Kafka template has got a send method where we can send a messaging method, and we can provide a message converter to provide some conversion on that message before it goes down to Kafka to do serialization. So in the next example, we've switched back to using string serializer within Kafka, but now I've told the Kafka listener annotation that we want to use a different listener container factory. As I mentioned, without this attribute there, it just looks for a bean called Kafka listener container factory. I have a second listener container factory called JSON listener container factory, and this one, this JSON listener container factory, this adds a message converter. So every time we create a listener container for that annotation, we're going to convert it. We're going to provide it with this JSON message converter. In addition, on the sending side, I've overridden the Kafka template bean with one that does a message converter. So now if I send a message via this Kafka template, it'll be converted from the domain object to a string, and then we're just using a string serializer in Kafka itself. So again, we're going to send another foo. And let's run this one. That's 5. Now, one thing, say the reason we're getting some history here is because I've reset the object. If I run it again, we'll just get the 1. One thing you'll notice is that we actually got back a bar object here. See, because if we look at our listener, the listener actually says, listen for a bar. It's a very common use case, particularly in sort of the microservices world, where we really don't want to have the same domain object, on the class path in every place. But if we have a type compatible object, then, and which bar is, right? So if I go look at bar, it's basically the same as foo. It's a simple domain object with foo and bar properties. So it's a type compatible, but it's a completely different class. The other thing is that you'll notice that I didn't in the listener container factory, I didn't have to provide any type to the message converter. The type is entirely inferred by the signature of the method. So we have a Kafka listener container that takes an object of type bar. That type is actually communicated to the message converter. So when the message comes in from Kafka as a JSON string, the message converter has knowledge about what the target method is for this message, and so then does a JSON deserialize into the bar object. I think that's pretty compelling feature. So I mentioned in the talk about the retry adapter. So in this case, what I've done is I actually changed the container factory for the listener to this retry Kafka listener container factory. We go back to the configuration. This has got a couple of additions in it. I added a retry template. Now this just adds a simple retry template, which you got the default retry, which is 3 attempts with no backoff. But you can add in, whatever configuration you want, whatever retry policy, whatever backoff policy, exponential backoff, or whatever you want into the retry template. And then we've got this record filter strategy where we can actually decide which messages we're interested in or not. So in this case, pretty simple. That if it contains bar, then we don't want that message. So I go to number 6. Yes, sorry.
So the retry is the same as the replay, or is it different?
Same.
Because in Kafka, Kafka provides ways to replay.
Yeah, no, this is sort of this is at the application level. So this is, we've received a message from Kafka. We're just doing in-memory retries. So if we run this one, number 6. And you can see I've just got some logic in here to see that, we received it, different attempts. So we received it attempt 1, attempt 2, attempt 3.
So if you had it set up to commit after every message,
It waits until retry succeeds or not. Now, yes, it's all done. Effectively, what we're doing is wrapping the listener. So from the container's perspective, it's invoked the wrapper, and the wrapper has the retry logic internally. If the retry fails and completely fails, then you can configure an exception handler into the into the listener container, and then decide what you want to do with that message. The other thing we have a setting on the container which says whether failures should be whether if you're using container commits, then you can decide whether you want failed messages to be committed or not. And then the last two examples are really just effectively the same thing, but instead of using the message listener, instead of using @Kafka listener, we're actually wiring in a container, listener container, and then implementing a listener object with the on message. So if we run that one, it's oops, number 7. So I mean, for, the trade-off, when would you use one or the other? No, there's a slight performance penalty of using a POJO because we're basically going through Spring messaging message, and obviously doing the there's another layer in the stack. On the other hand, if you implement message, if you implement a message listener, then you have to deal with the sort of lower level. It's not a POJO anymore. You're actually dealing with these consumer record objects. And yes, sir. Yes. So the retry template has a backoff policy. The default backoff policy is no backoff, so just boom, boom, boom. But you can add a simple backoff, so just wait a second and then retry, or you can have an exponential backoff so that it backs off.
Just a follow-up, we had their retries less than 30.
Mm-hmm.
So runtime, so it's going to retry again, right? Is there a maximum retry?
So the question is just is there a limit to the retries? It's completely configurable. If the retry template is part of the Spring retry project, which is in the Spring projects organization in GitHub, that actually started out in Spring batch, Spring retry, but it now has applicability across quite a number of the Spring portfolios. So we pulled it out of batch and made it its own project in its own right. But if you go to the Spring retry project, you see all the configure. There's lots of different policies. You can configure, retry for this exception, don't retry for that one. You can tell it to search the cause tree in an exception, so it doesn't necessarily look at the top level exception. You could say if this exception occurs anywhere in the cause tree of an exception, then it should retry or not, and stuff like that. So it's very, very flexible in terms of configuration. And then the last example is simply the same thing, message listener container. And this is just showing how we do manual acknowledgements. The only difference here is so in the listener container, see we've got this ACK mode. We're setting the ACK mode to manual immediate. Manual immediate means basically I want to do it effectively as soon as possible, bearing in mind that this is actually running on a different thread. So we'll wake up the consumer thread so that he'll actually perform the ACK right away. So that's what that one's doing. So that's pretty much it for spring-kafka. We as I mentioned, the spring-integration-kafka project is also available, which let me see if I can. I'm not sure if I have it on this machine. I think I do. Spring Integration has a samples repo, Spring Integration Samples, and there's this Kafka sample in there, which is, again, it's another boot application, and it just sends a bunch of messages to Kafka. And yes, so it doesn't use any XML for Spring configuration, but this is effectively the outbound channel adapter. This is invoked as a service activator. We have this Kafka producer message handler, which wraps a Kafka template. On the consumer side, we have this Kafka message-driven channel adapter. So people that are familiar with Spring integration, we effectively have an inbound channel adapter and an outbound channel adapter to send and receive messages. And you could go and look at the look at that sample to see. Let me see if I can. I should always. I've not actually tested this on this laptop, so but I'll give it a shot. I'm sorry, what was the question? You mean using the concurrent consumer? Yeah, no, I don't actually have one, but we can change that right now. Let's see. Yeah, it's got debug turned on. Let me just change that. So that sample, say, in this case, we're sending messages to the outbound channel adapter, and we're actually getting back these messages, and you can see the messages coming back with the various headers. So it's just the Kafka. It's in the basic projects in the Spring integration samples. So to answer the question, let's go to the well, let's go to this one. So instead of, now we have this Kafka message listening container, all I need to do is to change this to a concurrent message listener container. And I need to configure it, so let's and what I'm going to do is I'm going to set the container, set concurrency. Now, we got 5 topics in this partition, so I'm actually going to set the concurrency to 2. Okay, what doesn't it like about that? Oh, it's okay. So I'm going to set the concurrency to 2. So what's going to happen there is we're going to get a concurrent message listening container that delegates to 2 Kafka message listener containers, and one of them will get 2 topics and one of them will get 3. What's wrong here? Oh, and what I'll do is I'll turn on debug so we can actually see that. And this was number 7, I think. So let's So what happened was that when it first started, the first container got all 5, right? And then Kafka did a rebalance. So we can see we got not sure what. Not sure what's going on there. I never do live demos, right? But I have to see what's going on. But that's what happens is that each of those 2 instances, the topics will be assigned across the thing. But that's the basic configuration, is that instead of creating a Kafka message listener container, you create a concurrent message listener container and set the concurrency, and that will add the. Yes, sir. Do we support registry service? Oh, not at this time, not yet. No, this is it's a very new project. I mean, we're certainly use GitHub issues. Anything you want, we'll definitely consider. But no, there's nothing like that at the moment. Yes.
How would you recommend processing
in terms of, well, the default commit, if I should go to the act mode. Let me go to the previous. So we've got these act mode record, which is so we get a batch from Kafka. We'll commit after the record. We commit batches. I think I know what the question is going to be. So commit mode batch basically won't commit the offset until the listener has processed each of the messages. But the listener doesn't really know anything about that batch. And we actually have a request from on GitHub to say, could we provide an option where instead of spooning them out one at a time to the listener, if Kafka gives us 10, then have maybe a different type of listener, like a batch listener or something like that, where we give. So that's already an open issue on GitHub. Yes. Yes. So the question is how to not acknowledge if the downstream doesn't process. So yes, you would use one of the manual act modes and just invoke that acknowledge method. Now, interestingly enough, that acknowledge you can still do that in a POJO. So even if you're using @Kafka listener, if you add an acknowledgement parameter to your POJO method, then you can still do manual acts even if you're using the POJO Kafka listener. Well, I mean, obviously, as soon as the listener, if the listener returns, then you're using act mode, then that will never be act. You somehow would need to pass that acknowledge object downstream to whatever downstream component, and then have it. So if your listener does some call and doesn't get a response back, then you've got to somehow pass that acknowledgement, and somebody downstream has got to be responsible for calling that acknowledge method. If you're doing something like talking to a database, then obviously it's like a request response, and if you don't get a response, then you could not act it. Yes, sir. Kerberos support, pass. To the extent that the consumer currently supports it, then we support it. I mean, yes. So the actual ConsumerFactory and the ProducerFactory are very lightweight wrappers around the properties. So if it's a set of properties on that, then you can set those properties. So if the broker address is all you need to change, if you need to add credentials, then you just add them to those properties. The ProducerFactory and ConsumerFactory are also extensible. So if you need to do anything extra, then you can do that. But clearly, if there's anything that I'm really soliciting, ideas. This is a very early phase, so any suggestions, feel free to feed them back and/or contribute them. Of course, that was what my last slide said. Yes.
I was unclear on the consumer and producer factories, whether there were default ones that were sort of environmentally floating around, and if you chose to implement your own being with the same name, supersede, or whether it was your responsibility to always create consumer or producer factories.
At this time, you always create them. I did have an initial. I did sort of start a pull request into boot to have auto configure, where we did that, and we actually originally I had every Kafka property that's in the consumer configs and producer configs. I actually exposed those as boot properties, and the boot guys went nuts. They said, "No, you can't have 500 properties." So we sort of culled it down to what we thought was but it's very difficult to come up with a reasonable. what's good for one is not, somebody's going to say, well, why didn't you include this property? So, and we went back and forth with the boot guys. I think in 1.1, we're going to have some kind of auto configuration. It will probably be directly in spring-kafka using boot's auto. So if you're running in a boot app, then you'll get a ProducerFactory and ConsumerFactory with some opinionated defaults. And then you can use standard boot properties to override those defaults. So that's definitely on the roadmap for the next release. And we're really intending to release the 1.1 release sometime in the next couple of months or so. I mean, because we want to get support for the 0.10, the 0.10 client out there. Yes? So Spring Cloud Stream, the question is, does Spring Cloud Dataflow use this? Currently, the Spring Cloud Stream, so you can correct me if I'm wrong, uses the old spring-kafka for integration, which uses the 0.8 client. But Sobi Chacos is on our team. He's actually creating a binder for a Spring Cloud Stream that's built on top of this stuff. So that will be available reasonably soon, I would think. 1.1, okay. Yeah, so that's being worked on now. Currently, Spring Cloud Stream uses the old 0.8 client.
What's the story for having redundant instances of the same application that share that super
Cloud Foundry. Cloud Foundry, right? I mean, you can just scale it out, and then now it depends on what your application is, right? I mean, if you need strict ordering of messages, then you probably don't want to keep having partitions moved around all over the place. But yes. So the general idea is to start with more partitions than you think you'll ever need. And then those partitions will be allocated across instances as needed.
What's the story of not having a
I'm not a Cloud Foundry guy. I don't have an answer for that.
I believe the support the rule of
Yes, in 1.1, in fact, Marius and I have done a little bit of pair programming over Screen Hero over the last couple of months, and we've been playing around with the K-Stream stuff, and as soon as I committed the 0.10 upgrade this last week to the master branch. So the master branch currently supports the 0.10, and I'm expecting we'll start adding some Kafka Stream stuff in the next, well, certainly not this week because we're all here, but in the next week or so, I expect we'll have something. Sometime in the next couple of months. Because I say I'm keen to get, we have to make a choice of content versus time, right? So I'm keen to get support for, we're already getting people saying, why don't you support the 0.10 client? Because we actually released after the 0.10 client, but because they made API changes, it's made it a bit difficult for us. So I'm pretty keen. So I think we'll have some additional functionality over and above the 0.1, 0.10 client, but exactly what, I don't know yet. But so I'm keen to get something out soon. Then we can always do a 1.2 with more. I think this is going to evolve pretty quickly though. You mean an external? External? Yeah. It's something we're considering. I mean, we certainly had that in the old spring-integration-kafka mechanism, sort of an offset manager interface, and so yeah, I think it's something we'll get there. I don't have a timeline for it yet, but I think we will have support for it. I think we're over by a few minutes. If there are any more questions, otherwise, thank you for attending.